Welcome to my YouTube channel Tech Data Engineer. So today we will see resilient distributed data set, okay, RDD basically. So what is RDD and what are the key concepts of RDD, why we are using that, and what are their benefits, we will see in this video. So RDD is basically it's a resilient distributed data set, basically a fundamental data structure. So that represents a distributed collections of objects that can be processed in parallel. So RDD basically a fundamental way to the fundamental data structure that represent a distributed collections. Okay, so they have certain advantage. That's why we are using RDD sometimes, and data frame and data set. So there are certain things which we have to perform through RDD. So what are their advantage and all we will see in this video. Okay, so first we will see distributed nature. Okay, so RDT is basically a distributed across the node of a cluster. So as we know that in pyspark they have worker nodes and master node. So where computations are done on the executor, that are worker node, so RDD are distributed across the node of the cluster, which basically help us to do the parallel processing. Okay, so that is one of the feature. Then immutable is one of the feature. So what is called immutable? Once RDD is created, RDD cannot be changed. You can perform transformations on it to produce new RDD. So RDD is immutable. Once your RDD got created, it can't be changed. So you can perform transformation on it to produce new RDD. Then third is the fault tolerance. So RDD automatically recover from failures. So how? So what happens if certain point of time, if RDD got failed, then basically based on the lineage information, it will recompute the lost data in case of failure. So that is one of the advantage of RDD. Okay, so certain point of time, if there is some loss happen, so it will basically go to the back stage, and then it will check the lineage information, and then it will again do the recomputations. And then fourth is the lazy evaluation. So what do you mean by lazy evaluation? So RDD operations are lazy, meaning computations are not performed until an action is performed. Okay, so we will, until or unless, so there are two types of perform operations on RDD. The one is called transformation and other is called actions. So if we are performing any transformation, so what will happen, it will create a new RDD, and if we will perform any actions, it will change the existing RDD. So lazy evaluation means RDD operations are lazy, meaning computations are not performed until and unless an action is performed. So what is actions? Actions are like collect, count, or save text file. This is okay. So basically these are the key features we have. Okay, and apart from that, we have features like in-memory computations also. Okay, so what is in-memory computation basically? So RDD are designed in process data in memory, which speed up operations compared to traditional disk based storage. So in memory means whatever the computations RDD is doing, that is doing in the in memory, means RAM. Okay, instead of disk based storage like swap out, swap in when required. So that will take much time. So RDD have features for in memory computations, like it will do whatever the processing it will do in the memory itself. Okay, so apart from these key features, we have there are two types of operations we can perform on RDD. One is transformation and other is action. So transformations are basically, so transformations are, these are operations that create a new RDD from an existing one. Okay, transformations are lazy, meaning they are not executed immediately, but rather build a plan what needs to be done until or unless some actions are performed. Okay, so transformation basically lazy operations. So we have options like map, filter, flat map, reduce by key. This all these functions we will see in the next video. Here we will understand what are the transformation basically. So map, filter, flat map, reduce by key, these all are the transformation, and these are lazy operations. Until unless there is no action got performed, it will not create a it will just create a new RDD. It will not change to the existing RDD. Okay. Then other is the actions. These operations trigger the execution of transformation and return a result or write data to external storage system basically. Okay. So uh, so so in simple term we can understand like operation that create a new RDD from an existing one, such as map, filter and flat map, that are transformations. One more time. So if operation that create a new RDD, if there is a if that operation create a new RDD from an existing one, such as map, filter and flat map, that are called transformations. An operation that triggers computations and return a result, such as collect, count and first, that are actions. Okay. Okay, we have seen that. Now we will see what are the way where we can create an RDD. Okay, so like creating RDD, you can create RDD in several way, but parallelize a collections. If we have collections, you can use the parallelize method. Then you can create that RDD, or you can create the RDD from external storage system like HDFS S3 or local file system. Okay, from method like text file. Okay, you can do that. So here we will see that how to create RDD. So I have we have a list. We have already a list. Okay, local collections like list. We have already list 1 2 3 4 5. So we have used the method like sc.parallelize 1 2 3 4 5. Okay, then transform the RDD. So RDD we have options like map, flat map. So we have done like RDD.map lambda x. We have defined a function x where what it will do, it will take a number and it will multiply to the same number. If then if we'll perform, so first we have created the RDD from the list. Then we have RDD 1 2 3 4 5. Then we have performed some transformations. So in transformation we have used the RDD map method. Okay, so map method basically it will do the mapping. It will take each number and whatever the functions we have defined under the lambda. So this lambda function, what it will do, it will take a number, it will multiply with the same number. Suppose we have 1, it will write as output 1 into 1 equals to 1. We have 2, then 2 into 2 equals to 4. So it will multiply with the same number. Then if we'll perform some operations, then we will do so we have to take the result. So we have to do some actions on that. So what it will do, we will use a method called collect. So what it will do, square RDD is a transformed RDD. Then square RDD dot collect if will do, and then it will print the result. What it will print, from 1 it will print 1 2 4 3 9 4 16 5 25. So it will collect and it will print the result. Okay, so we have seen that what is RDD, what are their key concept, what are their benefits, why we are using. So one is the distributed nature, other is the distributed, we can perform parallel operations. Immutable means we can't change until or unless we will not perform any actions. Then the other is the fault tolerance, because of lineage graph. If certain point of time it got failed because of lineage graph, it will do the recomputation in memory computations. So here there is no overhead of in and out from the disk, so it will do the computation in memory. Fourth one is the lazy evaluation. Lazy evaluation means it will not perform any actions. So lazy evaluation basically uh, yeah, so lazy evaluations, it will, so lazy evaluations is basically do like RDD operations. So it means that computations are not performed until an action is performed. Okay, so that is the lazy evaluation. And there are there are two types of operation we can perform on RDD. One is the transformations, where we can create a new RDD, and there is the actions. So transformation functions are map. So sometimes it got asked also what are the transformation functions. So we can say that map, filter, flat map, reduce by key. And what are the actions, we have collect, count, first. Okay, reduce by key, save as text, not reduce by key, save as text. Okay, then what are the method of creating RDD? So we can create method from parallelize. If we have already list, we use the parallelize method, we can do that. Or if we have already the external file system, we can create it using the text file. So here we have taken example as a list. We have created an RDD, we have done some transformation over there, and then we have done the action on that. Okay, and then we have stored the result. That is the output code. Okay, thank you, thanks for watching.